Hi guys, welcome to week 7. Here we have your new worksheet for this week. We're talking about exponentials. So last week we did a little bit of work with exponents and we had your distance formula, your Pythagorean theorem, those types of things. Now we're going to see what happens when we change the power of your exponent. So here we just have some input-output tables. You can use a calculator for this, and we're going to plot points on the graph and then sketch that line that connects all of your points. So number 1, we're starting with 4 to the x power as my function. Remember, f of x is a function. It really is the same as if I said y equals 4 to the x power. Okay, so that's where my input-output table comes in handy. So for x equals 0, that means y is equal to 4 to the 0 power. And remember that anything to the 0 power is always 1. Okay, so that's your first value there. X is 1. That's saying 4 to the first power, which means we don't have any pairs of 4. It's just 4 all by itself. So it is 4. When x is 2, 4 to the second power, that's 4 times 4, so we've got 16. And then when x is 3, 4 to the third power, that's 4 times 4 times 4, or you can take 16 times 4 to get 64. Okay? So now we're going to take our values. Remember, these are like your points, right? 0, 1, 1, 4, 2, 16, 3, 64. And we're going to graph it. So 0, 1, there's my point there. And then 1, 4, 2, 16, and 3, 64 doesn't fit on our graph. But here's my sketch. It's going to be like a curve up like that, okay? So you're going to do the same for number 2. Let's look at number 3. This one's slightly different. We've got a multiply there. So order of operations says exponent first, and then we'll multiply. So for my first one, this says 3 times 2 to the 0. And we remember that anything to the 0 power is just 1. So it's really 3 times 1, which is 3. Okay. Then we've got 3 times 2 to the first power. 2 to the first power is just 2. So 3 times 2 is 6. And then we've got 3 times 2 to the second. 2 to the second power is 2 times 2. So we've got 4 times 3, which is 12. And lastly, 3 times 2 to the third power, which is 2 times 2 times 2, which is 8. So I've got 8 times 3, which is 24. Okay, now we just plot and connect my dots. So 0, 3 starting up here. Then 1, 6. 2, 12, and again in this case my 3, 24 is not fitting on my graph, but somewhere up here. So connecting my dots. Okay, so the nature of exponential graphs is this really steep curve upwards like that almost makes like a half of a U shape, like a parabola, but just that one side. Okay, getting into our word problems. Okay, we got Beamerland and zombies have invaded. 3 zombies were found roaming the halls on day 0, and they double in number. So day 1, we have 6 zombies. Day 2, we have 12 zombies, etc. Complete the input-output table, then plot the points on the graph. So here across my x-axis, that's my number of days. So my x is representing days. And then y is number of zombies. So on day 0, we were told that there's 3 zombies that would start off. And every day they are doubling. So become 6, 12, 24, 48, 96, 190. 96 times 2 is 192. And then 192 times 2 doubled is 384. Okay, so that is our input-output table. Now to graph some of these points. I know day 0, we're having 3 zombies, so somewhere over here. And then day 1, now we've got 6 zombies, so it's above my 5 mark there. Day 2, there are now 12 zombies, so a little bit above my 10. Day 3, there's now 24 zombies. Right there. Day 4, we've got 48, almost 50. Day 5, we've got 96. Sorry, up here, above my 95 mark. And then 192, we wouldn't be able to graph it in this case, but it would keep going up in that upwards, very steep curve trend, okay? And the rest of the questions you should be able to do based on our table and your graph. So number 6 is saying which equation, numbers 1 through 4 is equivalent to the scenario in number 5. So you're going to use some context clues, look at your input-output tables, see if it matches any of your input-output tables for numbers 1 through 4. How many zombies will there be in 10 days? So you're going to, you can continue your input-output table, or if you've figured out which graph it's like, which equation, you can use the equation and plug in 10. Number 8, if there are 400 or 1,450 students and staff in Beamerland, how long will it take for everyone to be turned into zombies? So you're going to figure out, when is my y equal to 1,450? And on which day will half of Beamerland be zombies? So you're going to take half of the students and staff and figure out what y value is that. And lastly, if the zombies spread to all of Federal Way, how long will it take for all of Federal Way to be taken over by zombies? Population is currently about 97,000. So you're going to be looking for a y value of at least 97,000. Okay. And the last word problem is going to be very similar, but we use the case of COVID-19. Okay. Similar questions, and you're gonna have to fill in your input-output table, graph it, and answer the following questions. Your answer key is attached below to allow you to check your answers, not so that you can just write the answers, because that's not really going to help you out, okay? So let me know if you have any other questions. You can email me, and see you on our Zoom meeting.